everyone. In the last session, we have completed our electrostats and we have also solved some questions also, previous question. Now in today's session, we are going to start a very new chapter, that is current and electricity. The very important thing about is this chapter, this is not involve any type of kinematics. Okay, from lot of students are afraid from the kinematics. Basically, there is no force, nothing will be there. Very simple equations we are going to use, current and electricity, and but as a competitive exam point of view, it will be slightly different what you have learned in your class 10th or 9th in about current and electricity. We will start today. In today's session, we are going to discuss about the class 10th basic. In class 10th, whatever you know about current and electricity, that we are going to start. I will give you some important point also, and then we will discuss about the resistance that you haven't discussed in your class 10th. So we will discuss that. It will be going a very easy session and easy lecture, that is not going to be very much difficult. But yeah, this chapter is a very scoring chapter in competitive exams also, because the questions are not going to be very much tough. If you know the basics, if you know the different laws and theorems and everything, then you can solve almost all the questions. So as a scoring, if you talk about the scoring, it is a scoring chapter and it is a very scoring chapter. Okay, so let us start with this. And myself Ritesh, and today we are going to start current and electricity. Okay, so let us start. So anyone who haven't covered basically electrostat can start this chapter, because there is no need of any basics of electrostat or nothing, because it is a completely different chapter. Okay, so current and electricity from NCERT, it is the third chapter, but we will cover it as a second chapter. Why? Because when we go to read electrostat, then it will be easy for us to cover the electrostat if we have covered the current and electricity. So first, in today's session, we will discuss about the basics of class 10th. Okay, basics of class 10th. Okay, we will discuss about the basics of class 10th with some extra point. Okay, with some extra point, not very much, but with some extra. Okay, that is going to be our today's discussion, so that you should have a proper basic of the all the concepts. Clear? Okay, so let us start. First, let me ask you a very simple thing. Do you know what is current? Or don't start with the current. Let me ask you a very simple thing. First, tell me what is electrical properties. What are the electrical properties you know? What is the electrical properties you know? Can you tell me about, name some electrical properties which you know from the knowledge of your class 10th? I treat that you don't know anything. Okay, so what are the electrical properties? Some electrical properties, can you tell me any one of the electrical property which you know? Okay, one is current. Yes, one is current. I of t. I'm just writing I of t. Just use write, note it down. Don't think about it. Okay, I of t. Okay, some other. Yes, sir. What is other? Voltage. Okay, voltage. Okay, V of t. Okay, some other property. Okay, power. Okay, P of t. Okay, some other property. Energy. What type of energy? Electrical energy. Okay, electrical energy. Okay, E of t. Correct. Okay, I understand. Means you know about some of the electrical property. That is clear. Okay, nice. Now let me start our discussion. Basically this whole current and electricity is built upon what thing? If you try to understand the this whole chapter is built on, build means its roots on charge. That is why we read first about the charge, and then we come to read about the current and electricity. Charge, that is Q of T. And what is Q? What is Q? Q of T, or, and I told you Q is the intrinsic property of the matter. This whole chapter is based on the Q. And Q is the intrinsic property of the matter. But in electrostats, we have seen that the charge is at rest. But in the current and electricity, the charge will be now moving. Now the charge will move. Now the charge is not at the rest. That is the important thing. In current and electricity, the charge is going to move. So basically, if you see, in class 10th, you have read one formula also. In class 10th, you have read one formula. What is the formula you have read? Basically, you have read about the Coulomb's law. Not Coulomb's law. Actually, I covered this, so I remember the name. You have read about Ohm's law. Okay, Ohm's law. My mistake. Ohm's law. What is Ohm's law? Have you read? We will read the proper statement of Ohm's law on the basis of competitive exam. But what you know in class 10, just tell me. You know, sir, the potential difference. First thing, potential difference, not potential. Okay, potential difference is directly proportional to the current that is flowing in a conductor. So from here we know that delta V is equal to I into R. That is a formula we know. Okay, delta V we know. What is delta V? It is a potential difference. We have understand the potential difference. Clear? We know about the potential difference. What is the current? Current is what? Current we know from the knowledge of class 10, that is I is equal to, I am writing general expression dq by dt. Remember, this expression is always valid. Always valid. Okay, this expression is always valid. Okay, whereas you learn about this expression I is equal to q by t. It is valid only when q is constant. When you are treating q as constant, then it is valid. Otherwise, it is not valid. Okay, so I we know, delta V we know. We have to discuss about what? R. I we know. We don't know about in very detail, but we know that I is equal to dq by dt, means rate of flow of charge. That how fast is the charge is flowing. Suppose there is a one person standing here and I flow a charge of 2 coulomb in 1 hour. Then how much will be the current? 2 by 60 into 60. The current is very small. He even don't feel that current. But suppose there is another person standing just beside me and I flow a charge of 2 coulomb in 0.01 second. What is the current value? It will be 200 ampere, and that will be the dangerous situation of his life. So that is what I am trying to say. Current is nothing but it is a rate of flow of charge, that how fast his charge is flowing. More faster is the rate of flow, faster will be the current, or sorry, large amount of the current will flow. That is a simple thing. Okay, so that is the thing we know from the class, basically class 10th. Okay, let us discuss some more things. Okay, so if I give you a simple circuit, for example, so suppose we have a simple circuit. This is what is this? This is resistance. This is a symbol of resistance. Unit is ohm. Okay, and I connected it to a battery. What is the battery? What is battery used to do? We will discuss. Suppose this resistance is 5 ohm. Okay, and suppose the battery is 10 volt. 10 volt. Then what will happen? What will happen? First, how much current it will flow? I is equal to delta V by R. Delta V by R. That is potential difference. You will say, sir, 2 ampere. Okay, just you got this answer. Correct. It is correct. It is not wrong. But let us think in a different manner. Basically, if you see here, this is what this is known as there is some wire is there. No? This is wire. This is what? This is called as a connecting wire. This is called as a connecting wire. Then what is the property of a connecting wire? Connecting wire means the resistance is almost what? 0. If resistance is 0, what I can say from here? If my resistance for the connecting wire is 0, so what I can say? My delta V will be 0. If my delta V is 0, I can say my V will be what? V will be constant. Okay, then means my V will be constant. And And we also know one thing, that is potential difference is like a potential energy. As we have to calculate the potential energy, we, like suppose there is a block keep on the ground, what is the potential energy? 0. If I bring it to a height of h, what will be the potential energy? mgh. So basically, if suppose at the ground I treat the potential energy as mgh, if I bring up to a height of h, then its potential energy is mg2h. So basically the difference is remain same na, the difference is not changing, it is initially also mgh and finally also mgh. It depend, we can take ground or you can take 0 at anywhere, wherever you want. At one place you can take ground to define the quantity at other place. Similarly we have done in potential also. At infinity we have taken the potential 0, but it is now a circuit. In circuit we have to take the if you want to define the potential at any point, what is the way of doing solving the circuit? We can take the potential 0 at any point in the circuit, at any point, at any one point you can take the potential equal to 0. Okay, because the potential difference is going to be remain same, it doesn't matter. If you take, like for example, let me explain you in better way. Okay, suppose there is a battery. Suppose there is a battery. Let us understand this concept. This is a battery of 5 volt. Suppose here the potential is 3 volt, correct? Then what will be the potential here? What is the potential here? So basically what you have to do, this is my higher potential and this is my lower potential. Just subtract, see what is the one thing I am sure, or basically first let me do one thing to understand it better. Let me do one thing. See, this thing is clear now. If there is a connecting wire, the resistance of connecting wire is 0 and that V is equal to constant. Basically what I am trying to say, while solving a circuit, solving a circuit at any one point, exactly one point, remember this, at any one point you can take potential equal to 0. This is not potential difference, this is potential equal to 0. So let us, for solving this circuit, let me draw this circuit again for you. Okay, this resistance is one more thing. In this chapter we are going to solve lot of circuits. So okay, so like if you want, so your calculation should be little faster. Okay, suppose this is the same thing, and now here we have a 10 volt battery. Now I suppose I am taking the potential here equal to 0. Suppose at this point the potential is 0. So as it is a connecting wire, the potential will be remain same. So here also we have 0. Similarly here we have also 0, correct? But if you come here, if you come, okay, this is 0, okay, correct. Now if you come here, what is the potential I have to choose here? See, there is a 10 volt battery. So what is, how much potential I have to choose here? That is my question. Can I tell here also the potential will be 0? Answer is no. Why? Because there is a resistance is there, na? I cannot tell the potential of this point directly. It can be anything. It can be positive, negative, anything. Or it can be 0 also. I don't know. Why? Because we can tell only the potential is constant only in the connecting wire. Okay, not in any element. There is no connecting wire. There is a 5 ohm resistor is there. So here also 0 volt. Here also potential is 0 volt. But here I can't comment. Now come here. Here we have a battery of 10 volt, and I want to know what is the potential here. How I can write the potential here? See, here we have a 0. One thing we know, that potential difference between, if I take this point and if I take this point, the potential difference is how much? Higher minus lower, that is 10 volt, correct? That is sure. The potential difference is 10 volt, means between these 2 points the potential difference will be always 10 volt. Whatever will happen, it will not going to change. Okay, so if it is like this and this is 0 volt, this terminal is 0 volt, so I can say na, if this terminal is 0 volt, so I can say one thing, what if this is 0 and the difference is 10, means what I am trying to say, let me bring this circuit, let me bring it somewhere else, let me bring it here. Suppose what I am trying to say, This is basically, let me draw it here. I am saying that this is 10 volt, and suppose this is my potential VH and this is lower because it is connected to the positive terminal of the battery, so it is at higher potential and it is at lower potential. This potential is 0. What I am saying, my VH minus VL is fixed, that is 10 volt. It is given because between these two terminals this is 10 volt. My VL is 0. I am saying I made the VL equal to 0 by putting, because I can assume one point at 0. So from here, what is my VH I will get? It is 10 volt. So I can say this point will be 10. If this is 10, this is also 10. This is also 10. Why? Because it is a connecting wire. Then it is also 10. Now you see here properly. Now you have a resistance. Now I am drawing this thing here. Now you can see properly what you observe. Here we have a, if you try, if just try to understand this thing, okay, it's very important thing, a very small thing, but it is very important. If you see this thing, now we have a resistance here, correct? This is 5 ohm resistance. Here we have a potential of how much? 10 volt, and here we have a potential of 0 volt. So can we know the potential difference? And there is a thing is that current always flow from, remember this node point, current always, it is always true, always flow from higher potential to lower potential. And you also know the one thing, that battery always give the current from the positive terminal. That is always true. But we will also see the battery always take the current, can also take the current from the positive terminal. That is also will come. But now you know one thing, that battery always give the current from the positive terminal. And this is higher potential, so this is lower potential, but current will flow like this, I. So what is the formula for I? I is equal to delta V by R, that we know. Okay, so what is delta V? 10 minus 0, that is 10 volt, divided by 5 ohm is equal to 2 ampere. Sir, from here also I am directly getting 2 ampere. Why are you telling this method? Because we are going to, now you will not solve the question by this, because this type of simple question won't come into your exam. They will make this circuit will be going to be the part of some bigger circuit. So you should know the approach now, how you have to solve the question. Now you are not going to apply this concept. Now this is the concept you are going to apply. This is the approach you have to follow while solving the question. And these are the very small points. See, basically I'm not going to teach you by the notes. There is no notes for me. I am going to tell you the concepts, whatever the concept that is important for solving the question. That is, it's because you have to solve the question. That is the only last thing. Okay, so this is the concept. First thing what you have to remember, at any connecting wire, okay, the potential is always same, and we can assume potential equal to 0 at any one point in the circuit, but only once, not everywhere. It doesn't mean that you take 0 also here, 0 also here, okay, then potential current is 0. Not like that. You can take potential equal to 0 at any one point in the circuit. That is I have written clearly here. I hope it is clear till here what I am trying to explain you. Is it clear? Please, if it is clear, please note it down, and if anyone have a doubt, please tell me. Is it clear? Okay. Okay, so let us go for some more discussions. Okay. So if I ask you a very small thing, okay, if I ask you a very small thing, that is current. Sir, current is basically dq by dt. Okay, sir. So let me give you one thing, means basically this is valid always, and I have given you, it is, this equation is valid always. Okay, sir. So let us say I is equal to 2t square plus some 5, and I ask you to find I average at t is equal to 2 seconds and find I instantaneous at t equal to 2 seconds. This is the question. Can you solve me and tell me? This is my I equation. Can you solve and tell me what is I average and what is I instantaneous? We know I is equal to dq by dt, and what is the unit? Coulomb per second, that is ampere, and it is one of the fundamental unit. If you remember, it is one of the fundamental unit of our what? SI units. So it is one of the fundamental. So yeah, so can you calculate what is I average and what is the instantaneous current at t is equal to 2 seconds? Well, both the values will be same or different? First, my question is whether both the values are same or different. Answer is different. But how to calculate I average? See, I average is defined as, that is delta q by delta t. Correct? Now first tell me, at t is equal to 0, what is my q? The q is 5 coulomb. At t is equal to 2 seconds, what is my q? What is my q? That is 8, 2 to the 4, 4 to 8, 8 plus 5, that is 13 coulomb. So what is my delta q? 13 minus 5, that is q final minus q initial, that is how much? 8 divided by delta t2, so we will get how much? 4 ampere. Are you getting my point? But if I have to calculate I instantaneous, that is I instantaneous, then what is the formula? That is dq by dt. Don't tell that you don't know the integration. You have to integrate the very simple integration. 2 into 2 e to the power 1 plus 5. Now what you have to do after integration, just put t is equal to 2. So what you will get? 2 into 2 into 2 plus 5, that is 13 ampere. See, both the answer are different. At t is equal to 2 seconds, we have a current of 13 ampere, but at t is equal to 2 seconds, the average current is 4 ampere. So that is, will be different in the answer. Similarly, if I give you this type of questions, for example, let's take one more example. Yeah, let's take, suppose my current is given as 3t square, or 3t square plus 6. I want to find my q at t is equal to 1 second. Can you calculate? Means my question is, you have given the current and can you calculate the charge? But now what you have to do? From this equation you take it. See, what is my charge? dq. dq will be I dt. Just integrate this. So you will get my q is equal to integration of I dt. Now what is the limit? At t is equal to 0 to 1 second. Now what is I is given? This thing is given, so it will become tq plus 3t square. Just keep limit, lower limit 0 to 1. So what is, you will get 4 coulomb. So that means I'm just giving you an example. If I give you the equation of current, so can you calculate the charge? And if I give you the equation of like charge, can you calculate the current? Okay, so this thing is clear, means no one have a doubt on this. Simple integration, differentiation you have to do and just calculate the thing. Okay, so till here anyone have a doubt? Basically what we have seen till now, this is the things we have seen about the basic. There is nothing going, we are not going anything beyond. Okay, we are just following the basic. Till now anyone have a doubt? Please tell. Are you clear? Till now anyone have a doubt? Okay, and if you study in class 10th, then you also learn about some series and parallel combinations. You have also learned about the series and parallel. In series, what you have learned? If there is a resistance, you have learned that if there is a resistance connected in series, suppose this is R1, this is R2, then what is R net? You have learned, sir, R net is simply R1 plus R2. And then we have seen one more thing, that if there is a resistance connected in parallel, suppose it is R1 and we have R2, then my 1 upon R net is equal to, sir, 1 upon R1, sir, plus 1 upon R2. Okay. Yeah, so these things you know. This is the basic idea of your class, basically class 10th. So these all things you know, I hope. Clear? Now let us start. This means these things you know, everything. Okay. So now let us start our preparation for competitive exam. These are the basic things which I want to tell you. So it is completed. So basically we have completed the class 10th basic now. Okay. Now you can start the preparation for your competitive exam. Okay. So let us start the first thing, competitive preparation. Okay. Or you can say now chapter is started. Okay. So now we are going to start the chapter. Till now we are discussing just the basic thing. Okay. So our first discussion will be what? Discussion on current. That is, what is exactly a current is. That is our first discussion. So let us talk about. Basically, you know that is I is equal to dq by dt. Okay. So the unit is coulomb per second. That is equal to ampere. Okay, sir. And if we have I equation, then and from here I can say my dq is also equal to integration of I dt. Okay, simple. Means these things you know. These things I hope you know. And suppose now let me ask. Now let us go for the comparative aspect. So suppose there is a suppose in this branch the current is 8 ampere, and in this branch the current is 2 ampere. So can you tell me what will be the current? Suppose the angle between them is 90 degree. So can you tell me what is the current in this branch and what will be the direction? Here the current is coming 8 ampere and here the current is going 2 ampere, and the angle between these two wires are 90 degree. So can you tell me what is the current in this branch and what is the direction of that current? How much? 6 ampere. So on what logic you have told 6 ampere? Sir, there is 8 ampere is current is coming, 2 ampere is going here, so only 6 ampere will be left and that will go here. Okay, so the direction will be like this. So first let me ask you one question. If suppose I won't give this direction, suppose if I won't give this direction, nothing. Okay, suppose I won't give this direction, and then I will ask you, okay, suppose now 8 ampere is coming, can you tell me what is the value of current in this branch? You can't tell because you don't know the direction of this arrow is there. Okay, just because you don't know what is the direction, basically you don't know. Wait a minute. You don't know what is the direction of this 2 ampere. It can be in this direction also, it can be in this direction also. You can't comment about this current. For commenting about this current, you know this, you have to know this direction, then only you can comment. Are you getting my point? So that means, what does it means? What is the meaning of this thing? Can anyone tell me what is the meaning? If I am saying 6 ampere here, the direction is here, what is the meaning we are getting? The meaning we are getting is that for a current, the direction is very important. It has a magnitude as well as direction also. So from here we can conclude, I got my point. From here we can conclude, from here we can conclude that I has magnitude as well as direction also. But sir, then it is a vector quantity. Answer is no, it is not a vector quantity. Why? If it follow the triangle law of addition, so can you tell me the angle is 90 degree na? So the current value should be under root of 8 square plus under root of 2 square. That should, according to the vector law of addition. If you study my vector lectures, then it should be, this current should be, it is a resultant, so it should be under root of 8 square plus 2 square, correct? And the direction should be something like that according to the vector, but we are not getting this thing. So what is the reason? Actually it is a vector, it is a quantity which has a magnitude as well as direction, but it does not follow the law of additions, vector law of additions. Whatever the vector law of additions you have studied, that is triangle law, parallelogram law, polygon law, it does not follow those laws of addition. So basically it is a vector, it is a quantity that has a magnitude as well as direction, but not follow the vector law of addition. So it is a which type of quantity? That is why it is called as a tensor quantity. Sorry. That is why it is called as a tensor quantity. But in your exams, if they will ask you what is the answer, then you have to tell it is a scalar quantity, because in your syllabus sorry, because in your syllabus there is nothing like a tensor quantity. So what you will treat it as a simple scalar quantity for your syllabus, for your point of view. But in reality it is a scalar, it is not it is not a vector quantity, it is or it is also not a scalar quantity, it is a tensor quantity. But in your syllabus there is no tensor quantity, so you have to treat it as a normal scalar quantity, but the direction is important for current. So one new thing we have got in comparison of class 10th. Okay, have you understand this thing? Okay, so what you have to conclude, that is a current is a tensor quantity, but if there is no option, then we will treat it as a scalar quantity. Simple is that. Clear? Okay, now there is another terminology is there, that is something called as a current density. That is defined, that is called as a current density. Now what is current density? Let us talk about. That is also another terminology that has been defined. Okay, so suppose we have a conductor, correct? Okay, I am drawing the conductor. Suppose we have a conductor. Okay, suppose like that we have a conductor, and suppose I have applied the potential here V 0. Here the potential is V, here the potential is 0. So the electric field will be obviously in this direction, because the direction of electric field is decreases in the it is along the potential. Okay, correct, like that. We have learned the formula, learned the concept also. It will be something like this. So this is my electric field, correct? Electric field is there, so the what will be so we will get the current is also in this direction, correct? Now let me take a small cross section. Let me take a small cross section of this. Okay, let me take a small cross section of this. So for this cross section the current is like this, and this is a small cross section. Suppose the area is A, area is equal to A. So we have defined something called J, that is equal to I by A, whose unit is what will be the unit? That will be, it will be ampere per meter square, and that is called as a, this J is called as a current density. Okay, current density. So what is current density? Basically current density is defined as a current per unit area. But what will happen if suppose I take a suppose some another cross section like this, means I change my cross section. Okay, I have taken this cross section, then my area vector will be like this. And initially my area vector is, initially what is my area vector? Initially my area vector is along the current. Now the area vector, this area vector is suppose a dash, and initially it is a. Now if I have to write my current density, what I will write? My current will be how much? First tell me what will be my current. If you see, suppose the angle between them is theta. So my current I will write, I will take this area a dash, or I will take the component of a dash along a. I have to take the component of a dash along a in this case, so it will become a dash cos theta into how much? J, sorry, into j, correct? Or I can write it as like this also, j a dash cos theta. And as it is a theta is an angle between the current and the area vector, so I can say my I is equal to j dot a vector. So basically we know that current is not a vector quantity, so similar to that current we have defined another quantity that is called as a j, current density. So I is defined as a j dot a, where what is a? A is the area that is perpendicular to the direction of current. Okay, that is why we have taken not a dash, we have taken a dash cos theta. Okay, means suppose this is my area, okay, then current is going like this, so obviously this area will be perpendicular to my current, so my current density will be current. What is my current? Current divided by this area of cross section, correct? So that is what I have defined. Okay, if my area is suppose like this and current is going straight like this and my area is like this, what I am trying to say is, suppose my area is like this, suppose my area is like this, correct, and my current is going straight, it is going straight, but my area vector is like the angle between them, I have to take the component of the area vector along that current, so I have to take the component of that area vector, because area is a vector quantity, it is not a scalar quantity, we know this thing. So that is how we have defined. So area we have defined as area that is perpendicular to the direction of the current, that area you have to take. Oh, so see here, this is my current and the area which is perpendicular to the current is this area, not this area, it is this area. So this area we have to take the component of this, then we will get this area. So basically you have to understand the I is equal to j dot a, clear? Where theta is, what is theta? Theta is going to be the angle between I and area vector, correct? Any doubt till here? Okay, note it down first. These are the small terminologies which has been defined. Completed? Have you understand the concept? Now let us talk about some history. Basically, if I ask you one thing, suppose there is a conductor is there, okay. I haven't applied any electric field, nothing, okay, nothing is applied there, no potential, nothing is there, and it is a conductor, okay. So can you tell me, is there will be any current? No, there will be no current, obviously, because we don't have any potential difference, no battery is there, okay, no current. But I ask you one thing, why the current is flow? Due to the motion of electrons, because there is positive charge cannot move, okay, because it is inside the nucleus, only electrons can move. Okay, it is true, sir, we are getting, but if the body, this conductor is there, it is keep it like this, here also we have a free electron and they are also moving, but we are not getting any current. Why? Here also it is electrons are moving also there, na? It doesn't mean that we haven't applied any force. It doesn't mean that the electron is at rest. In this conductor also the electrons are moving, still moving, the electrons are still moving, yes or no? But why we are not getting any current? What is the reason? Because suppose this is my electron, okay, what is the motion will be there? It's seal. The motion will be something like this, okay. So if you will see, it will start at its own point and it will again come to its own point. So because if you calculate here, what is the speed of electron? Speed of this electron, speed of this electron is non-zero. Obviously it has some speed, but what is the velocity of this electron? Velocity is defined as total displacement upon total time. What is the displacement here? Zero, because initial point and focal point are zero. What is average speed? Average speed is non-zero, but what is average velocity? Average velocity, if you will calculate, it is again zero, because total displacement is zero. So average velocity, if you will calculate, it will be again zero. Means at a room temperature, when no field is applied, I is equal to 0, because of this reason. If you will see, this is the reason. This is the two reasons due to which we are getting, because the total displacement is 0, because total displacement, if you will see, it is 0. There is no total displacement. The total displacement is 0, correct? Okay. So what will happen if we apply a field? Suppose I have applied a field, then what is going to be happen? Let us try to understand the picture. What is going to be happen if we applied a field there? Okay, suppose I have applied the field, then what is going to be happen? So I am taking this is my first case. Okay, now I am going to the second case. Now I have applied the field, so let me apply the field on it. Correct? Suppose this is my electron, and let me apply the field on it. Then what happen? If you will see, what will happen? You will see, so you can see from here, now there is some displacement is there. Now you can see properly, there is some displacement we are getting. Let me make it more clear for you. Now you can see from here, this is the initial point and this is the final point. So basically this is my initial, this is point 1 and this is point 2, correct? These are the 2 points you are getting, and you are seeing that there is some distance is covered. That distance is called as a lambda, which is termed as a mean free path. And the velocity and the average velocity by which this distance has been covered, the average velocity by which lambda is covered is called drift velocity. Basically here we have applied the electric field. There is an electric field is there, correct? There we have an electric field here. Drift velocity, that is given as Vd. So what we have seen, that when we have applied an electric field, we have find that now the electron is again making the random motion only, but now here it is, the electron is covering some distance, and the distance is called as a lambda, which is known as a mean free path, and the velocity by which it is covering that distance, that velocity is called as a drift velocity. Okay, that average velocity is called as a drift velocity. And in this case, if I ask you this thing, what is my average, what is my first thing, you tell me what is my speed? Non-zero. What is my velocity? That is also non-zero. What is my average speed? This is for electron only. Okay, for electron, clear. Average speed, it is again non-zero. And what is my average velocity? That is also non-zero. Means in this case, now you can understand at room temperature, when there is a no field is applied, what is the case, and when we have applied the electric field, we are getting this case. So there is a difference is there in two cases completely. So that is what happened, and due to this reason only we are getting a current here, because here in this case you are getting a some displacement, the electrons are able to move. So what the assumption is taken, because they are going, now we have to do the some calculations, so we cannot take this so much like this motion is very difficult to analyze. So what they have done, they have taken some assumptions. What are the assumptions they have taken? The assumption is very clear. Let me write for you. Let me give a picture for this, the assumptions what they have taken. Let me draw for that. Let me give 1 minute. 1 minute. Okay, so this what they tell this thing is now equivalent to this thing. What they have assumed is this is my conductor, and when we have applied the electric field, okay, suppose we have applied the electric field or potential, whatever you can say, both are exactly same only. What they have assumed that obviously if I am applying electric field here, the electron will move in this direction. So what they have seen, the positrons, the opposite of electron is positrons. Positrons are moving in this direction, in like this, like a person's move in a parade. That is the assumption they have taken. It is in reality it is not like that, but for derivation purpose we have taken that this thing is equivalent to this thing. This is equivalent of this, equivalent of that. Okay, and this is the assumption we are, and we are going to, whatever the derivation we are going to do, we are going to take this as our as our model, not as this as a model, and then we will derive the everything. Okay, and one more thing, like whatever the, like what they are going to do, basically there are the collisions will be going to be happen, that is obvious, because there will be some collisions will be there, correct? Or let me write here, basically suppose this is my one electron, or just you understand this, Suppose I'm drawing this, zoom, I'm zooming this. So this is my initial point 1 and this is my final point 2, correct? That is my final point 2 that we have seen. Are you getting my point? So as these 2 points are there, I told that this distance is lambda. What is the time taken to cover this distance is tau. And what is the velocity here? What is the velocity here? That is Vd. This is the picture you should remember. Clear? This is the picture you should remember. Okay, this picture should be in your mind. This is the final picture. Are you getting my point? This is a story which you have to remember in same the manner I have remembered this story, because it is a very important thing. Are you getting my point? Okay. Till note it down. Note it down. If anyone have a doubt till here, please tell. Clear? Now we have to derive the formula for drift velocity. You understand what is drift velocity now? So relation of Vd, that is drift velocity with current. So now our model should be clear in your mind, and why the current is no there when there is no electric field. Clear? So let us see the things properly and try to understand the proper things, proper each and everything. Okay. Suppose this is my conductor. Now you know the picture. When we apply the electric field, the electron will move like a person who are moving in a parade. But for an electron, we are taking positron. Okay. So suppose initially at time t equal to 0, electrons are here. After some time t equal to t, these electrons will move from here to here. Correct? Like this. Are you getting my point? Initially, the electrons are moving like this, and suppose at instant t I have seen the electrons are crossing this surface. Now after some small time t, they have crossed this surface. So what is the distance they have covered? The distance they have covered is Vd into t, correct or not, from here to here. And what is the area is this? This area is A. Are you getting my point? So n, for this material we have defined something called n. What is n? That is called as a number of electrons per unit volume. Correct? So what will be the total charge that is flown from here to here? That is total charges, how much? N into volume V dt into A into E. Are you getting my, sorry, 1 minute. Okay, N Vd, then T, take 1 minute. This should be Vd into dt, small time duration dt. Okay, so dt, this is my volume. So in this volume, that much charge is there. Are you getting my point? In this volume, that much, electrons are there. That much electrons are there into that. What is current? Electron, like my d cube is equal to this much electrons is there into charge on one electron. So that will be by total, means number of electron into charge, that is equal to, because we know q is equal to n into E. So this thing is going to be my n. Are you getting my point? And that is my charge q. So from here we know one thing. What is dq by dt? Dt will bring down, it will become n E A Vd. And what is dq by dt? So this is my I, that is equal to n E A Vd. So from here we get a one formula, that is very important formula, that is relation of current with drift velocity, that is I is equal to Ne है Vd. Okay, remember that what is n? N is number of electrons per unit volume. Clear? So what will be the unit? Unit, you know, that is 1 upon centimeter cube. It will be like this. So you remember this formula. So I hope it is clear. That is a small formula. From this formula only we are going to derive the Ohm's law. But generally for law there is no proof. But if we want, we can do. Let us see how we can do this. We have seen that, suppose these are my 2 points. We have seen that if this is my point 1 and the electron is moving from point 1 to point 2 in the conductor, are you getting my point? In the conductor, how much distance is covered? Lambda. How much time it will take? That is tau. That is something called as a relaxation time. Relaxation time. And lambda is mean free path. What is the velocity here? Vd. And as there is an electric field is also there, E. So I can write one thing. What is the one thing I can write? That is lambda is equal to half QE by m into tau square. Correct? Array S is equal to ut plus half at square. U is 0, so half at square. Correct? This thing is clear or not? First, you tell me. This equation is clear or not? Lambda is equal to half QE by. This thing is clear. Are you getting my point? Okay. And if I ask you what is by Vd, what is the Vd you will write? What is the Vd? It will be lambda by tau. Correct or not? It is lambda by tau. Are you getting my point? Vd is what? Lambda by tau. Just put this value here. So what you will get? So from here we can say my Vd is how much? From this equation, my Vd is how much? That is half QE by m into tau. Okay, Vd is equal to, from here I can say my Vd is half into QE by m into tau. Correct? Now let's proceed this derivation further. One more thing we know. What is that one thing? If suppose the potential, we generally won't apply any field, we will apply the potentials. Here the potential is V, here the potential is 0, and suppose the distance, the length of the conductor, suppose the length of the conductor is L. Basically the length of the conductor is L, electric field is there, and the potential at this is V, this is 0. So we can write my electric field is what? That is V by L. That we know, correct? V by L. Now you can use this thing here, and let us combine, use the equation number 2. Let us use this is my second equation, and they both are the formulas, but we are going to use this formula to derive the Ohm's law. Okay, both are the formulas. This formula should be in your notes. Okay, so let use the equation 1 and 2 by 1 and 2. Okay, first equation is I is equal to NEA into Vd. Correct? And what is Vd? Vd we have got half into E divided by m. Correct? Into tau. Just put this value here. So what you will get? I is equal to NEA into half into E into capital E divided by m into tau. So what you will get, and just put, we know E is equal to, we also know E is equal to V by L, that also put it here. So you will get you will get N E square A by 2 M L into, in numerator we will have a tau into V, and that is I. If you will see, this whole thing is what? This whole thing is constant at a fixed temperature. If you fix the temperature, then whole thing is going to be the constant. So we are getting from here, that is I is directly proportional to V. And so this thing is what? This thing is my resistance. Resistance is defined as N E square A by 2 M L. Are you getting my point? Just note it down. sorry, one mistake. One mistake is there, just correct it. Let me correct this, because we know resistance is directly proportional. So from here you just reverse this. So V is equal to, you will get how much, 2 ml by n E square A into, sorry, A into tau, that is I. So from here we can say V is directly proportional to I. So this thing is nothing but, what is this? This is resistance. So resistance is how much? 2 ml upon n E square A into tau. And if you will see it properly, you will find one more thing. You will find one more thing. We know from class 12th basic, from class 10th, okay, class 10th, we know R is equal to rho L by A. This thing we know now. So if you compare this thing here, you will get my rho is equal to 2m upon n E square into tau. This unit is what? Ohm. And what is the unit of resistivity? Can you tell me what is the unit of resistivity? What is the unit of resistivity? It will be ohm per ohm meter. It is ohm meter, not ohm per meter. It is ohm meter. Are you getting the point completely? So this is how we prove this is my Ohm's law. Basically, if you want for board, it is important. For competitive exam, it is not important. Just you remember these two formulas. These two formulas are very important, very important. In the next to next session, they are very important formulas. Okay, that is R is equal to 2 ml upon, and there is a something we define also called as a conductivity, sigma. Sigma is called as a conductivity. Okay, conductivity, that is nothing but conductivity, that is nothing but 1 by resistivity. Okay, so one more thing is there, you can write it as sigma meter inverse, and similarly we have a G, that is called 1 by R, and it is, sorry, this is ohm inverse, meter inverse, and this is also ohm, this is, sorry, this is ohm basically, or you can say this is ohm inverse. Okay, this is called as a conductance. So in today's session we have seen a lot of things. Okay, we have seen a lot of things basically. If you will take a look, then we have seen a lot of things, I hope. Okay, so these are the small formulas. So we have in today's, this thing is not important, only you remember this formula and this small terminologies. I am giving you the conclusion in the next page. Just remember the conclusion. See why I am writing the conclusion, so that if you want, if you don't have a time, you can just directly see the conclusion and just remember the things. Okay, so basically what we have seen, first we have seen I is equal to NEA into VD. Then we have seen my VD is equal to half E, capital E by M into tau. Then after that, what we have seen our resistance. Resistance is equal to 2 ml upon n E square A into tau. Then after that, we have seen our resistivity is equal to 2m upon n E square into tau. Correct? These are the formulas we have seen. And also we have seen something called G, that is equal to 1 by R. And the next thing we have seen something called as a sigma, which is equal to 1 by rho. Are you getting my point? 1 by resistivity. These are the formulas we have seen, and some more formulas like this formulas, you know, V is equal to I into R, that is you know I is equal to V by R, that you also know. Okay, R is equal to V by I, that also you know. Just I am writing for you. These are the formulas we have seen. We have also seen one more thing, that is current density, that is J is equal to I by A vector, or you can say my I is equal to j vector dot a vector, correct? And what is the how to find this? We have also seen this. Okay, so this is our today's session. We have seen a lot of things about it. Till here, anyone have a doubt? They can tell me. So I hope you enjoy this session. So in the next session, we are going to discuss about the resistance, because we have calculated the resistance formula, that is 2 ml upon Ne square A into tau. We will discuss about something about more in resistance. So in today's class, we have clear your class 10th concepts, and then we went for some comparative concepts. In the next session, we will see about the resistance. Till then, take care, goodbye, and if you like the session, please like it, share it, subscribe it, and have a nice day. Thank you.